Hello YouTube! We're on the Real Programming channel. It is about HTML and CSS. My name is Andrei. This is our 65th lesson. I greet you. We will talk about the cascade. So to review, as the page authors, we can use multiple style sheets with our HTML. And the user might also supply his own styles. And then the browser has its default styles too. And on top of it all, that we might have multiple selectors that apply to the same elements. How do we figure out which styles an element gets? That's actually another way of asking what a cascade does. The cascade is a way a browser decides, given a bunch of styles in a bunch of style sheets, which style is going to be used. To answer that question, we need to bring everything together, all the various style sheets hanging around the rules, and the individual property declarations in those rules. In the next 2 pages, we are going to step to the nitty-gritty details of how all this works. The details involve a lot of shortening and various details of determine which rules are the most specific with respect to an element. But here is the payoff. After going to the next 2 pages, you'll be able to get to the bottom of any styles that don't seem to be applied in the way you expect. And future, you're going to understand more about the cascade than 99% of the web page developers out there. We're not kidding. So let's talk about the cascade. For this exercise, you need to be the browser. Let's say you got an H1 element on the page and you want to know the font size property for it. Here's how you do it. Step 1. Gather all your style sheets together. For this step, you need all the style sheets. The style sheets the web page author has written. Any style sheets that the reader has added to the mix. And the browser default styles. Remember, you the browser now, so you have access to all this stuff. Step 2. Find all the declarations that match. You were looking specifically for the font size property, as look at all the declarations. For font size that have selector that could possibly select the H1 element. Go to all the style sheets and pull out any rules that match H1 and also have a font size property. Step 3. Now take all your matches and sort them. Now that you got all the matches rules together, sort them in the order of author's reader browser. In other words, if you wrote them as the author of the page, then they are more important than if the reader wrote them. And in turn, the reader styles are more important than their browser's default styles. Remember, we maintained that the reader could put important on these CSS properties, and if he does that, those properties come first when you sort. Step 4. Now sort all the declarations about how specific they are. Remember, we talked about this little way back in chapter 7. You can intuitively think about a rule being more specific if it more accurately selects an element. For instance, the descended selector Blackwater H1 is more specific than just this H1 selector because it only selects H1 inside of Blackwaters, but there a little recipe you can follow to calculate exactly how specific a selector is, and we'll do that on the next page. Step 5. Finally, sort any conflicting rules if they appear in their individual style sheets. Now you just need to take the list and add any conflicting rules so that the ones appearing later, closer to the bottom of their respective style sheets, are more important. That way, if you put a new rule in your style sheet, it can override any rules before it. That's it. The first rule in the sorted list is the winner, and this font size property is the one to use. Now let's see how you determine how specific a selector is. Welcome to the What's My Specificity game. To calculate the specificity, you start with a set of 3 numbers like this. 0, 3, 0. And then we just tally up various things from the selector like this. Does the selector have any? It's 1 point each. Does the selector have any classes or pseudo-classes or 1 point each? Does the selector have any element names? And 1 point for each. For instance, the selector h1 has 1 element in it, so you read this as the number 1. Both h1 and h1 point blue have 1 element, so they both get a 1 in the rightmost number column. As another example, the select h1 point blue has 1 element and 1 class, so you'd read this as number 11. h1 blue also has 1 class, so it's get 1 in the middle number column. Neither has it in its selector, so they both get a 0 in the left number column. After you tile it up all its classes, the elements, the bigger the specificity number, the more specific the rule. So since h1 blue has a specificity of 11, it is more specific than h1, which has a specificity of 1. Sharpen your pencil. Try your hand to calculate the specificity of these selectors using the rules above. There are no dumb questions. What makes a specificity number bigger than another? Just read them like real number. 100 bigger than 10, which is bigger than 0, 0, 1, and so on. What about a rule like h1, h2? What is the specificity? Think of that as 2 separate rules. An h1 rule which has a specificity of 0, 0, 1 and h2. Rule that also has specificity of 0, 0, 1. Can you say more about the important thing? The reader can override a style by putting an important one the end of his property declaration like this. I can get the reader's style sheets. So how can a few ever figure out the way the cascade works? You can't, but look, it is the way. If the reader overrides your styles, then that is really beyond your control. So just make your pages look like you want them to using your styles. If the reader chooses to override them, then he'll get what they asks for better or worse for worse. Putting it all together. Woohoo! It's time for an example. So, say you want to know the color property for this h1 element. And let's take this to all these cascade steps. Remember, use the browser because you're trying to figure out how to display this h1 element. Step 1. Gather all your style sheets together. Usually you're the author, the person writing the CSS, but right now you're the browser. And that's you. The person using the browser is the reader. Step 2. Find all that declaration that match. So it's a reader, it's a browser, and it's an author. Step 3. Now take all your matches and sort them by auto reader browser. It's author, reader, and browser with reader. It's author. Here is where just recorder that rules by author, then reader, and then browser. Step 4. Now sort the declarations by how specific they are. To do that, we need to first calculate each specificity score and then record the rules. And the rule with the blueberry class moves to the top because it has the highest specificity. Notice that we only sort within the auto reader and browser categories. We don't resort an entire list, or else the body h1 rule world move about the h1 rule set by the author. Step 5. Finally, sort any conflicting rules in the order that they appear in their individual stat sheets. H1 blueberry and H1 color, it's the author. H1 it's the reader, H1 color black, it's the browser. We're okay here because we don't have any conflicting rules at this point. The blueberry was a score of 11 and is a clear winner. If there had been rules with a score of 0-11, then the rule appearing latest would be the winner. We have a winner. After switching to the first choice of elements, the sorting, more sorting, and being judged on specificity, the H1 blueberry rule has risen to the top, so the color property in the H1 element will be blue. And there are no dumb questions. And finally, of chapter Divs and Spans, we'll talk about this in the next lesson. And this is our 65 lesson is over. Thanks for watching. Subscribe to my channel, please. Like, share with friends, comment. Eat bananas, chocolate, drink more water for the effective work of our brains. That's all. Bye.